Hello guys, and welcome back to my channel. In this video we're going to be going over how to draw Newman projections in a step-by-step fashion. Essentially, you will be given a structure, and now this structure, if it has dashes and wedges, where this would be a dash and that would be a wedge, would mean that this is in the fence post projection. But before we get into the video, guys, I want to do a little bit of a disclaimer. When I was in this course, my professor always called these fence post projections. Okay, so this is just a huge habit of mine to refer to a wedge and dash compound. So this in a textbook, I just am looking right now in the David Klein Organic Chemistry 2nd edition. He refers to this type of drawing as a wedge, and dash. But before we get into the video, I just want to do a quick little disclaimer. When I draw this type of structure, I will be referring to it as a fence post projection. This is just a bad habit of mine because when I took this course, my professor would always call these fence post projections, okay? But if you look in a textbook, they might refer to this drawing as a wedge and dash, which I have just referenced with the David Klein Organic Chemistry 2nd edition. But I also looked online, and a few people also call these bond line structures, but they all mean the same thing. So yeah, let's get into the video, but I just want to do this quick disclaimer so nobody gets confused. So this structure right here is now shown to you in a fence post projection. And you will be asked to convert the fence post projection into a Newman projection. Where a Newman projection, to draw this, all you need to do is you need to draw one circle with a dot in the middle, where you draw 3 bonds extending from the central dot. And you draw 3 bonds going away from the back of the circle. We will get into what this means soon. So now, step 1 is you will be told the angle that you are looking at the fence post projection from. So here, let's say you will be looking at the fence post from the left-hand side. And picture this as an eyeball. So this is an eyeball. Picture the eye looking down this axis. And now this axis will be told to you by the professor, okay? So right now the eyeball is on the left-hand side eye. And the left-hand side eye is looking down a C-C bond axis. So 2 carbons, where here the front carbon, the purple carbon, would be C1. And the back carbon would be C2. And now we can see C1 and C2 both have 4 bonds. The bond that exists in between C1 and C2, the pink bond, is not drawn in the Newman projection. So that bond is technically like right there. And it attaches C1 to C2, which is in the back. But you do not draw in C2 on your Newman projection, because when you're looking at this structure in the fence post, carbon 1 hides the rest of the bond, attaching it to C2, so you do not actually see C2. This bond is hidden, but you must know it is there. But with that said, you must know that it is there. You cannot forget. Instead of drawing an eye, which is what you will probably be given in the question, I like to make this eye into a person. So pretend that this is actually a head, and I'm going to draw a little person, okay? In the exact same position that they told me the eyeball was in. I'm going to make this into a person, okay? Pretend I'm like a little person at the park. So at the park, there's going to be a ground that you stand on, and then there's going to be the sky. So down here, this would be the ground. And now up here, this is going to be the sky. On your person, you must draw in your arms as dashes and wedges. So if you stand to the left-hand side, so this was a left-hand side eye, so now this is still a left-hand side person. Your left arm will be on a dash going into the page, and your right arm will be on a wedge going out of the page. So the dash is going to be your left hand, and then the wedge is going to be your right hand. And this always is the same, okay? If you were standing from the right hand side, it would be the opposite, but we will do an example of that in the next question. So now, picture you are standing face to face with this Newman projection in the park, okay? And you are looking at C1. So we've already drawn in C1 at the front of the Newman projection, so right there. And now we've got to say, okay, let's draw in what's on the left-hand side. So left-hand side of the Newman and the right-hand side of the Newman. So whatever hand is on a dash, and if that hand is on the left-hand side, on carbon number 1, the atom on the dash will also be on the left-hand side. So let's say, let's draw our left hand on a dash in green. We can see that the hydrogen attached to C1 is also on a dash, so that means it must be drawn going out and away from C1 on the left-hand side. So now for the bromine matches up with the right-hand side, so the wedge. So it must be drawn on the right-hand side of my Newman projection, pointed up. Why? Well, it's pointed up towards the sky. See, if we extend this wedge, it's pointed up towards the sky. If we extended the hydrogen, it's pointed up towards the sky. So same for the bromine. The bromine will be drawn on the right-hand side of the Newman projection. Now finally, for the third bond, we have a CH3 group. The CH3 group was not drawn in, but every dot, so this is a dot carbon at the end of a bond, must have 4 bonds. So we knew that this was a carbon and it had to have 3 bonds. Well, those 3 bonds, if it's not drawn in, that means it's a hydrogen. They just expect you to know that. So this was a CH3. So I could draw on those 3 H's, or I could just say this is like a CH3. So this CH3 is pointed down towards the ground. So that means attached to C1 on the Newman, I must draw it down towards the ground, CH3. So now, all I have to do is indicate which bond is which, going away from C2, which is the bond at the back of the Newman that is once again hidden by C1. So now, here's the fun trick. Wedges stay on the same side as wedges, dashes stay on the same side as dashes. So we already figured out which atom on C1 was on a wedge, and that meant it was on the right-hand side. And we already figured out that the atom on the left-hand side was the atom that was on the dash. So this stays consistent with C2. So now you just need to figure out, do I draw this bond towards the sky, or do I draw this bond towards the ground? And we can see that here the bromine group is pointed down towards the ground. So I must draw it on the right-hand side, down towards the ground. And I must draw the other hydrogen down towards the ground on the Newman. H. If we said this is H1 and H2, this guy would have been H1, this guy would have been H2. That's BR1, BR2. This would have been BR1, this would have been BR2. And then finally, we got our CH3 group attached to carbon number 2. But this CH3 group, if we extend this bond, it's pointed up towards the sky. So we must draw that CH3 group going up towards the sky, which would be like, this would be the CH2 group attached to C2. But once again, we do not draw in C2 in the Newman projection. We just have to know it is there. It is being hidden by C1 because you are looking at this structure face on. And now this would be your Newman projection if you were asked to draw this structure from the indicated angle. We will get into which Newman structure will be the most stable in a different lecture, but this question, I was just going over how to convert a fence post projection into a Newman projection. So yeah, that was the first question. We can do another question. So step 1, you have to figure out, okay, which side and what orientation am I looking at this fence post projection. All right, step 1 is you have to figure out which way you are looking at the fence post projection. This will be given to you. So let's say this time they draw that eyeball on the right hand side. So what do? Well, we gotta turn that eyeball into a human being. So we actually draw a little human being. But this time, our dash arm is going to be the right arm. So do you see the trend here? The dash arm will always be the same hand as whatever side the human is on. So the dash here is going to be the right hand. And then the wedge will be the left hand. Before this human, the dash was the left hand. And then the wedge was the right hand when the human was standing from the left hand side. Just to be clear. So if you were standing on the left hand side on the same structure, it would look like that. So the left hand would be on the dash and the right hand would be on the wedge. But right now, we are saying that we are standing from the right hand side. So let's focus on that. So now I must look down the C1, C2 bond axis. So here, the blue carbon would be C1 and the purple carbon would be C2. So let's look down the bond axis. Boom. And we have to pretend we're at the park. So at the park, you have the sky with the pretty clouds. And you got the ground that you were standing on, the grass. Okay. So now we got to draw in our Newman projection. So we draw in a circle with a dot. And that dot is going to be the carbon that is closest to me. And when I say me, I am saying that I am the stick man that we drew in pink. So this would be C1. Okay. So now on my fence post projection, they did not draw in the wedge on C1 and they did not draw in the dash on C2. So we must draw those in. Every carbon must have 4 bonds. So here the 4th bond on C1, which is going to be the wedge, has to be a hydrogen. And the dash on C2 must also be a hydrogen. So now we just have to match up our hand in the stick person with the bonds on carbon 1. So the carbon closest to you. So here we can see that the dash, which is our right hand, matches up with the chlorine. So you have a left hand side and you have a right hand side. And now on my right hand, we have the chlorine. And is it pointed to the sky or the ground? So extend the bond, it's pointed up towards the sky. So all we got to do is draw it pointed up towards the sky. Sky, ground, on the right hand side. So our chlorine would go there. So now we have the hydrogen, and the hydrogen is on the wedge. And the wedge is indicated by my left hand. Left hand, hydrogen. So that means it has to go on the left hand side of the Newman projection, and it is pointed up towards the sky if we extend that bond. Hydrogen. And then pointed down towards the ground, boom, is a CH3 group. So on our Newman projection, going away from C1, we must also draw the CH3. Bada bing, bada boom. That is it. So now we can draw in the substituents of carbon 2. So going away in carbon 2, we cannot see it, but it is back there. We have already established which atoms on C1 line up with the right and the left side. So match up your wedges and your dashes. So the hydrogen on C2 is on a dash. Dashes are on the same side as dashes, so it must also be on the right-hand side, hydrogen. The bromine is on a wedge, so it must be on the same side as the atom that was on a wedge on C1. So it must be on the left-hand side, bromine. And now we drew these down towards the ground because in the fence posts they were extending down towards the ground. Now finally we have our third bond, which is the CH3 group. And we can see this bond, if we extend it, is pointed up towards the sky. So we must draw up towards the sky. Bada bing, bada boom. That is our Newman projection. Alright, now finally for our last example. Ooh, this looks a little bit more tricky. Yes, but it's still the same thing, okay? Step 1, figure out how you're looking at the fence post. So let's say this time they tell us the eye is on the right-hand side. So instead of an eye, I'm going to draw in a person and draw in a dash and a wedge arm. So my dash arm is going to be my left hand when I stand from the right. And my wedge is going to be my right hand when I stand from the right. So now I must pretend I'm looking down the C1, C2 bond, down. This would be C1, the purple carbon, and then the blue carbon would be C2. So now I must draw a circle with a dot in the middle of it. This dot is going to be the carbon that I am closest to in my stickman drawing. So this would be C1 here. So now I have to see which atom is on a wedge, which atom is on a dash. And they will line up with the same side as my hand. So this would be my left-hand side, my right-hand side. So my left hand, this drawn in green, is on a dash. So whatever atom is on a dash will also be on the left-hand side of my Newman. But now I just have to figure out, okay, is it pointed towards the sky? Sky. Or is it pointed down towards the ground? Here, if you extend the CBr bond, it is pointed up towards the sky. If you extend the CH bond, it's pointed up towards the sky. If you extend the C phenyl group bond, it is pointed down towards the ground. I hope you get the gist. Let me know if you don't, though, in the comment section down below. So here, the hydrogen would be pointed up towards the sky on the left-hand side, H. Now the bromine group is pointed up towards the sky on the right-hand side, up towards the sky on the right-hand side. And now the phenyl group is pointed down towards the ground. That is it, that is all. So then, remember, the bond between C1 and C2 is hidden. It's like drawn right there, but it's imaginary. All the way to C2. But once again, we don't actually draw this in. You have to know it's there. So we must draw the atoms, how they are arranged around C2 in the back. So now we already established on C1 which atom was on the left-hand side, which atom was on the right-hand side, by looking at which atom was on the wedge and dash and how that aligned with our stickman drawing, okay? So now for the carbon number 2, wedges are on the same side as wedges and dashes are on the same side as dashes. So nice. So the chlorine is on a wedge, so we know it has to be on the right-hand side. Easy. And the CH3 group is on a dash, so we know it has to be on the left-hand side. Now the only question is, okay, is it up towards the sky or down towards the ground? Here we can see these two atoms are closer to the ground. We can also extend the bond and say, oh, they're both pointed down towards the ground. So we must draw them down towards the ground. And what I mean by down towards the ground is I mean down here rather than up here. So if you split this circle in half, down here would be ground stuff, and up here would be sky stuff. chlorine group is pointed down towards the ground on the right-hand side. The CH3 group is pointed down towards the ground on the left-hand side. And now our little snake tongue is pointed, or isopropyl is pointed up towards the sky. Boom. Going away from C2. Little isopropyl. And now think, this bond right here, it keeps extending down and it actually attaches to C2. But once again, we're just not drawing that because we're standing and facing this fence post projection head on. So this bond is hidden. That is why we're not drawing that in. But we are pretending that these bonds are all extending back and touching C2. So this would be our Newman projection. That is it. That is all. I hope this video was helpful. Let me know if you have any questions, and have a great day. So this is a summary of how to draw a Newman projection from a fence post projection. We can also start in a Fisher projection, but that would be a separate video. And we can also